Hi, in this video, we're going to look at what's known as differentiation from first principles. We're going to look at this GeoGebra app here, and the GeoGebra app will be in the link to it will be in the notes of this video. So here we got the function f of x is equal to x squared. It's quite a well-known function. And what we're going to try and do is try and find the gradient at this particular point here. The coordinates of this point here are 1, 1. Okay, and we know we can find the gradient of this by if we can find the gradient of this tangent line here, this red line here. It actually has an equation of 2x minus 1, so therefore the gradient is 2. But we're just going to see how this works using this idea of differentiation from first principles. So first thing I'm going to do is I'm going to click here, and I'm going to put another point. So I'm going to imagine this point, Q, is x plus a little bit of x, which we call the little bit of x we call h, okay, and f of x, the x coordinate, x plus h, is x plus a little bit of h. At the moment, h is equal to 2, so here we've got what's known as a chord, okay, and we can find the gradient of that chord by take rise divided by run, okay, the vertical over the horizontal. So this distance here is going to be the y difference of the y coordinates. It's going to be f of x plus h minus f of x, okay, and at this particular point it's going to be 8 because h is 2, so this is actually the point 3, 9, okay, and so we just got 3 take away 1, which is 8, and then here we got 3 take away 1, sorry, we got 9 take away 1, which is 8, and then 3 take away 1, which is 2. So this distance we call h is called h, okay, and we can see the gradient here is going to be f of x plus h minus f of x, okay, so this would be this one here, sorry, my bad, this will be the x plus h minus x, which will just give h, okay, so that would just be 8 divided by 2. We can see the gradient of this blue dotted chord here is going to be 4. Now what we do is we try to make h very, very small. So what we do, we're making h small, and you can see that the gradient is actually decreasing here, and we make it very, 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 very small like that. Okay, and we can see what it's doing. It is approaching the number 2, which is what we expected to do. And what you can also see is that the chord is getting very, very close to the tangent, okay? The smaller I make it, don't know how small I can do it on this, the more closer it does. If I start using the arrow key, I can start making it really, really small. Okay, and what you can see is that for values, small values of h, that the gradient is approaching 2. Okay, we're going to make h, you can see where h being very, very small here. Whoops, can't make it 1. Okay, so as small as I can make it on this thing, we can see that the gradient is going to be 2.001. But I can make it infinitely smaller than that, okay? And that's called taking the limit as h approaches 0 of the gradient function, which is f of x plus h minus f of x divided by h, okay? So what you do is you make h extremely, extremely small, infinitely small, but not equal to 0, and that will allow us to find the gradient. And what you can see by the diagram is that actually that chord also virtually now coincides with the tangent, which is the gradient of the curve at that particular point here, P. Okay, and then if you did it with a set of tables here, for that was our original starting point, and then remember we got the gradient being equal to 4, and then we can move it to 4, and then we move it really, really small, and we got to the one that we've actually got here, 2.001. Okay, and then we can use this to differentiate from what's known as first principles. It's also a nice idea to be able to do it, okay, in other videos I will show you how to do that. But meanwhile, this has just been an introduction onto what's known as differentiation by first principles and how it actually works. Okay, I hope you've understood, and I thank you very, very much for watching. The GeoGebra app is in the notes of the video, along with my link to all my other videos. and maybe you could consider subscribing to my channel. Thank you very much.